Hey, what's up everybody? Welcome back to my channel. Salman Iqbal here. You can follow me on Twitter at SolmanIqbal, trainer at LearnK8. On this channel, we talk everything cloud native. In this video, we're going to be talking about GitOps. If you have been following Kubernetes happenings for the last few years, you've probably been seeing GitOps pop up everywhere. And the interest over time in it has been gradually increasing. It all started in 2017 when our friends at Weaveworks introduced the world to GitOps. They showed us the patterns and principles behind it. In this video, we're going to be looking at what GitOps is and is it something that we should be learning about. So let's get started. The idea behind GitOps is straightforward. Use infrastructure as code for all the scripts that you need to create, update, or delete your infrastructure. You can use a number of tools to help you with this. Terraform, Pulumi, and even YAML to name a few. And then you save everything in Git. Your infrastructure files, application files, state of the infrastructure, everything goes in Git. Then we automate everything. Deployment of apps, automated. Updating the infrastructure, automated. We can use any of the tools that are available to us. And then we have automation that triggers all of our scripts. Let's see an example of this. Let's create a Kubernetes deployment file that includes a single replica that will run a LearnK8's red container in our Kubernetes cluster. We take this resource definition and commit the deployment definition in Git. And as soon as the changes are committed to Git, the automation is triggered to deploy the changes to our Kubernetes cluster. Usually we have two choices. We can either push a change or cluster can pull the changes. In GitOps, we usually have a pull-based operator that watches the state of infrastructure and applies those changes. This executes kubectl apply and the app is deployed in Kubernetes. Now you might ask, what is an operator? When we create a deployment in Kubernetes, in the control plane, the deployment object is written to etcd database. There is a controller, which is a piece of software that is watching this deployment object. And the job of the controller is to create the required number of pods in the etcd database. An operator is a custom controller that we write the logic of, and it extends the Kubernetes functionality. So going back to where we were, we have automatically updated our infrastructure from a commit. Now you might be thinking, I already do this. How is this different? Well, the devil, as usual, is in the detail. Let's look a couple more scenarios. Let's say you wish to increase the replicas of your running app from 1 to 3. What we should do is take the old manifest and modify it and increase the replicas to 3. Just like before, we take that file and commit the file into Git. Now the state of the infrastructure is stored in Git. As soon as the change is committed to the repo, our automation triggers a redeploy to the cluster. As the state is stored in Git, we know we need 2 more replicas to get to our desired state of 3. The automation executes kubectl apply on the cluster and we get 2 more replicas deployed and we end up on our desired state. Please do know that if the cluster is running in production, the change has to come from a commit in Git. Let's look at another scenario involving Kubernetes Autoscalar. Let's say we have 1 replica of our app running and the Autoscalar decides it needs to increase the replicas from 1 to 3 to meet the increased demand. Usually you would let the Autoscalar do its thing and let it scale replicas in Kubernetes cluster. Not in this case though, this is GitOps. Every change has to go through Git. What the Autoscalar does instead is to increase the replicas by writing the number of replicas as 3 in YAML file and committing it to Git. As soon as the change gets committed to the Git repo, the automation triggers a redeploy to the cluster. kubectl apply gets executed and the app is deployed in Kubernetes with 3 replicas. So hopefully we have started to realize one thing by now. In GitOps, every change goes through Git. Always.
But why?
Imagine someone deletes the entire cluster by mistake. Worry not. The entire state of the cluster is stored in Git, including the number of replicas. We can trigger the automation and redeploy the same infrastructure as before. And just like that, the cluster is back online with a deployment that has 3 replicas. Now, in the previous case, if the Autoscalar did not update the replicas by committing to Git, we could lose some details about our infrastructure. The GitOps process ensures that we do not compromise the state of our infrastructure and we get back to where we were. Powerful stuff. There are other benefits too. In order to deploy to any environment including production, you do not need to be an infrastructure engineer anymore. You only need to learn Git in order to trigger changes to infrastructure. Another advantage is that your changes have most likely been reviewed by a colleague before they're committed. We also have an audit log of all the changes that have happened on our infrastructure. Just check out the Git history. We can roll back to any point in time, check the history, and carry out Git revert. So the question is, should you look into GitOps? Well, yes, you should. Of course, there is some work that needs to be done if you want to incorporate GitOps into your project. However, benefits discussed earlier are great. Also, if your infrastructure for whatever reason starts to drift from the configuration stored in Git, this will be automatically overwritten by automation. I should mention that GitOps is not limited to Kubernetes. You can use this on any platform in which the infrastructure can be described declaratively using infrastructure as code tools. There are some great projects out there to help with GitOps. You have Flux, Argo, Jenkins, just to name a few. I have added links to these projects and other references around GitOps to the description of this video, which you should definitely check out. So in summary, use infrastructure as code to set up your infrastructure, save all your resources including the state of the infrastructure in Git, and let the automation take care of updating your infrastructure. Any change you or the system wants to make has to go through a Git commit. Hope that gave you a bit more understanding on what GitOps is and how it differentiates from normal CI/CD. If you'd like more details on this topic, I have included some links in the description. If you'd like to see more content like this, please consider subscribing to the channel, sharing with your friends and colleagues. Until next time, thank you very much for tuning in. Stay safe.